Hello, and welcome to today's lesson on factors affecting the Earth's temperature. In today's lesson, we'll begin by exploring how the rates of absorption and reflection influence the Earth's temperature. Then we'll learn why the equator receives more direct sunlight, leading to higher temperatures compared to the poles. Next, we'll explain how temperature fluctuates during the day. Lastly, we'll examine the effect of clouds on temperature. So far, you have learned about how the balance between radiation absorbed from the sun and radiation emitted back into space affects temperature. Building on this foundational knowledge can now delve deeper into specific factors affecting the Earth's temperature. Understanding these concepts will enhance our grasp of climate patterns, weather forecasts, and the impact of human activities on global temperatures. The Earth's temperature is influenced by multiple factors related to how radiation is absorbed, emitted, and reflected. Here's how each process works. The sun emits energy predominantly in the form of visible light and ultraviolet radiation. When this radiation reaches the Earth, it is absorbed by the surface, warming it up. Darker surfaces like oceans and forests absorb more radiation compared to lighter surfaces like ice and snow, which reflect more. After absorbing solar radiation, the Earth's surface will re-emit energy back into space in the form of infrared radiation. This emission is crucial because it prevents the Earth from continuously heating up and helps maintain a balance. The Earth's temperature is essentially a balance between the solar radiation that is absorbed and the infrared radiation that is emitted back into space. Any factor that alters this balance can affect the Earth's temperature. For instance, different surfaces have different reflectivity, or albedo. For example, snow reflects a lot of radiation, while forests absorb more. Similarly, greenhouse gases trap some of the outgoing infrared radiation and reflect it back towards the Earth, further warming the atmosphere. Their increased concentration in the atmosphere likewise affects Earth's temperature, which we'll explore in the next lesson. The equator experiences higher temperature compared to the poles. This is because the sun's rays strike the Earth more directly at the equator, concentrating energy over a smaller area. The higher radiation intensity means more energy is absorbed, leading to higher temperatures. At the poles, however, the sun's rays strike at a steeper angle, distributing the energy over a larger area. This results in lower radiation intensity and hence lower absorption and temperatures. Now let's look at temperature variation throughout the day. As the sun rises, its rays start to heat the Earth's surface. The surface gradually absorbs more radiation throughout the day, causing temperatures to rise. Typically, the highest temperature are reached in the early afternoon, because by then, the Earth has absorbed the maximum amount of solar radiation. At night, the part of the Earth facing away from the sun receives almost no radiation, leading to cooling as the Earth emits infrared radiation back into space. Finally, let's consider how clouds influence temperature. Firstly, during the morning, clouds can reflect a significant portion of incoming solar radiation back into space. Less radiation reaches the Earth's surface, leading to cooler temperatures. In contrast, at night, clouds act like a blanket, trapping heat and reflecting it back onto the Earth's surface. This reduces the amount of infrared radiation that escapes into space, leading to warmer nighttime temperatures compared to clear skies. To sum up, the Earth's temperature is governed by the rates at which it absorbs, emits, and reflects radiation. The balance between incoming solar radiation and outgoing infrared radiation is crucial. This explains why there are higher temperatures at the equator and during the day. Factors like cloud cover, surface type, and greenhouse gas concentrations can significantly alter this balance, affecting both global and local temperatures. Understanding these concepts helps us explain daily temperature variations and the broader implications for climate and weather. Watch the rest of the GCSE physics course at Sophos Education.